Okay, so I believe if I give you an array containing some elements like 3, 7, 1, 9, 4, and I ask you to rotate this array, then this statement is not complete. To make it complete, you should ask me a few things. First thing is, in what direction you want me to rotate it? Because you can either rotate it in a clockwise way, okay, or you can rotate it in anti-clockwise way. So first thing is direction, and second thing is how many units of rotation do you want to do, right? So these two things are very important. So let's say if I say I want to do a clockwise rotate, okay, I'll refer clockwise rotation as right rotation, and anti-clockwise I'll refer as left rotation. So let's say I want to perform k units of right rotation, okay. So what will happen is this 4 will come and sit at the front. So you'll get 4, 3, 7, 1, 9. On the other hand, let's say you wanted 2 units of right rotation. In that case, 9 and 4, both of them would have come and sit at front, and this is what you would have got. So what we can say is, if the value of k is 1, then the last one element comes and sits at the front. Everything else remains same. And if let's say the value of k is 2, then the last two elements come and sit at the front, and everything else stays the same. Okay, so that is how rotation happens. Cool. So now that we understand this idea, if I ask you a very simple question, that I'll give you an integer array containing n elements, and I want you to perform 1 unit, just 1 unit of right rotation. 1 unit of right rotation. Can you write a very simple code and get it done? Just 1 unit of right rotation. Okay, cool. So I believe you don't have to do a lot of things to get it done. This is a very easy question. So if let's say your array looks 5, 1, 10, and 2, then what you actually want is, you want 2 to come at the front, and you want everything else to slide towards the right side. So you want 5, 1, 10 to come over here. Now, if you take a look over here, you want all the elements apart from 2 to jump towards their right side by 1 unit, isn't it? That is the reason 10 came over here, 1 came over here, 5 came over here, and the last element will go and sit at the front. So maybe what I can do is I can just store the last element in some variable. Last element is this. And then for all the elements before the last element, I can just push them towards 1 unit right. You can just write a simple for loop for it. So you can say for I equals to n minus 2. So you can start pushing the elements in this direction from here to here. I equals to n minus 2, and then I greater than equals to 0, I minus minus. Okay. So let's say when your I is over here, you want this element to go and sit over here. So you can say that array of I plus 1 should be made equals to array I. So when this piece of logic executes, 10 will go here, then 1 will go here, 5 will go here, and finally what you have to do is array of 0 should be made equal to x, which was nothing but the actual last element. So this is just an order n logic to get your problem solved. Or does that make sense? Just type in yes or no. Right? Okay. So let's say somebody wants k units of right rotation, and you have written this function. Now, because this function, when called once, performs 1 unit of rotation, if you call it k times, it will perform k units of rotation, right? So by that also you can perform k units of rotation. It's up to you. But the con of this thing is that its time complexity will be k into n, because every time you call it, it is taking n time. So if you call it k times, it will be like k into n. And there is a better way to do it. Okay. So if you have not gone through that, please go through it. It will be very helpful. I'll switch to a different question today, which I want to discuss. And that you should be able to solve if you have just understood what I have discussed till now. So let's say we have an integer array of size n, and this contains positive elements only. Let's say this array contains elements like 2, 4, 1, 6, 3, 9, 8. Okay. Now what we want to do is we want to segregate odds and evens. Okay, so what I want to do is all the even elements should come first and all the odd elements should come later. So here, how many even elements are there? 2, 4, 6 and 8 are my even elements. So in my resultant array, I don't have a separate array, right? I have to do everything in this array only. I have to rearrange this array only such that all the even elements, which are 2, 4, 6, 8, should come at the beginning, and all the odd elements, which are 1, 3, 9, should come at the end. This is what I want to do. And to do this, I do not want to use any extra space. So order 1 space constraint is there. Okay, I want to do this using order 1 amount of space. Do you all understand what the question is asking from you? Just typing yes or no. Okay, I will make one more thing very clear over here. When I said I first want evens and then I want odds, please bear it in your mind that instead of 2, 4, 6, 8, do not keep it something like 2, 6, 4, 8 or 2, 8, 4, 6. Why? Because I want relative order to be same. What do I mean? What do I mean by relative order? Relative order means that in the original array, 2 was coming before 4, 4 was coming before 6, 6 was coming before 8. So that should be honored. So here also 2 should come before 4 and 4 should come before 6, 6 should come before 8. And with respect to 1, 3, 9 also, what should happen is that 1 should come before 3 and 3 should come before 9. So I want to ensure two things. First evens, then odds, and across evens, relative order should be honored, and across odds also, relative order should be honored. Did you understand this relative order part? Just type in yes or no. Okay, let us make this question a little easy for you. What if I allow you to use extra space? So I have allowed you extra space. Then do you think this question can be done very easily? Store array with evens and then odds. Yeah. That looks like a good idea. So guys, look, in reality, think how your how your mind would function if you want to segregate the odds from evens and you want to ensure the relative order. You'd want to have two buckets, right? And let's say in this bucket you are collecting evens and in this bucket you are collecting odds. So maybe what you can do is you can start from here. If you see an even element, just put it in even bucket. Again even, put it in even bucket. Odd, put it in odd. Again even, put it in even. Odd, put it in odd. Odd, put it in odd. And finally even, put it in even. So what has happened is all the evens have come here and all the odds have come here. And also, if I use something like array or vector to store these elements in these buckets, then these elements naturally would have appeared in their relative order. Because 2, if it comes before 4, it must have appeared before 4, right? So I can have two arrays. First array stores even elements and second array stores odd elements. You can have vector also. In fact, I would encourage you to use vector in this case because you are not sure beforehand that how many evens and how many odds will be there. So rather than using two arrays of random sizes, why not use two vectors? Do you understand this point, that why I would like you to use two vectors to store these rather than two arrays? So let me just tell you one thing. These are some of the use cases where you should be able to decide whether to prefer array or vector. These are tiny things, but they matter a lot in interviews. I mean, somebody using a vector would be considered better if you are using an array of random size rather. You know, you can use array also, but in that case, you would want to first count that how many evens and how many odds are there. So let's say if m even elements are there, then you would want to create first array of size m and second array of size n. But that does not look too good, right? Because you're doing one extra iteration just to figure out the sizes of your arrays. So that doesn't seem so good. Anyways, so once this is done, then your job is very easy. Then what you can do is you can start scanning the first vector from the beginning, and whatever you see, you put it at front. Then you see 4, you put it 4 here. Then you see 6, then you put 6 here instead of 1. Then you see 8, you put 8 over here, and then scan this array and put these elements at the end at whatever slots are remaining. But this is going to consume extra space. So how not to use extra space and solve this problem? Okay, so one of you is saying for every index we check if it is even. If it is, else we rotate till we find even number at. It's not so clear what you have written, but I believe you are thinking in right direction. Anyone else who can do it without, extra space? Okay, let me tell you one thing. When I'm asking you not to use extra space, I'm not pressurizing you for time complexity. Just let time complexity fly high even if it flies high. Don't worry about that. Okay. Partitioning the array into 2 segments. Yeah, but then your partition has to somehow also ensure the relative ordering. We can keep on swapping events with odds in the order they appear. Okay, multiple thoughts. Cool. So let's talk about it. I'll tell you one thing. Some of you are planning to kind of either sort the array using quick sort or some other sorting algorithm. So I'll probably use their subroutines. That would not be needed. Okay. Even by using simple concepts of rotations, you can solve this question, and let us understand how that can be done. Okay. So set k equals to 0. If element is even, then set array k to element. Okay. Let me talk about some approaches over here. So let's say this was your array, and you had a 5 here, then you had a 7 here, then you had a 9 here, and then you had a 4 here. Okay. So once you start scanning the array, till this point, you are totally okay. Why? Because you have just seen odd elements. You have not seen even any even element. But here, when you see an even element, you realize something is wrong, because this is an even element. This must appear at the beginning. Now, there are 2 ways to make it appear at the beginning. First way is that I swap this 4 with this 5. So if I swap 4 and 5, what will happen is that I'll get 4 over here, and then you will have 7, 9 followed by 5. So it looks like a good way, because what you have done is you have pushed this element at the front because you want evens to appear before odds. But what is it which is wrong with this approach? What will not be ensured by this thing? Yes, relative order. So relative order will not be ensured by this thing. This is an important thing to understand. If relative order constraint was not there, then this question was not a hard question to solve. I'll tell you why. Because now you can keep on following the same trend. What is the trend? You somehow keep track of the first index, or you somehow keep track of the index of first odd element. Let me write it. Index of first odd element. So here the index of first odd element was 0. So you swap this 4 with 0, right? And now once you swap it with this, then you can then you need to update your index to 1. And then what will happen next time? Again, let's say after 5 you see 11, you won't do anything. But after that, let's say you see 2, then you can just swap this 2 with this 7. When you swap this 2 with this 7, it will come here and it will go there. And then again, you need to update your index to now become equal to 3. Do you understand that why I am tracking that index? It is important for me. If I don't track that index, I'll not be able to decide that if I am encountering an even element, what to swap it with. Does that make sense? Just type in yes or no. If you don't get that, I can probably talk about it again. Okay, why I am saying index of first odd element? Because if the index of first odd element is over here, now because it is an odd element, it is guaranteed that everything before it must have been even. So if you encounter an even element somewhere, then in order to put it in this group, you must want to swap it with this, so that this 4 comes here, and whatever was over here that goes over here. So let's say there was an odd element 11 here, it came here. And now you can change your index to point to the, let's say you had a 13 over here, so your index should now be this. Now you can say that this entire thing is events. So maybe this is one approach that you guys can take. Okay, does that make sense to everyone? The problem with this approach is that it is not going to ensure relative ordering. So how to ensure relative ordering? Can somebody talk about that? Okay, so can I replace my swap operation by rotate operation? Can I do something like this? Yes or no? Good. So let's take a look. Let's say you had an array where you first saw some odds and then you saw some even element, let's say 2. Now, once you are at this 2, what do you actually want? You want that this 2 somehow comes over here and all these elements still maintain their relative order. So think of it in this manner. If I rotate this much of array by 1 unit, it would mean bringing this 2 here and pushing all these elements towards their right side by 1 unit. That would mean that 2 comes here and 5, 7, 9 come here. It is totally okay for you now because now you haven't disturbed their relative order. So I'll replace swap operation by rotate operation. So if let's say the index of the first odd element is known, and if that index is idx, and you encountered an even element at j, then what you are going to do is you are going to perform 1 unit of rotation in this array, which is from idx to j. Does that give some kind of idea? Just type in yes or no. Right? Think and tell me, will it increase my time complexity or not? It will definitely increase my time complexity, isn't it? It'll surely do so. And why it will do so? Let us understand it. Swap operation happens in order 1 time. Swap is constant time operation, but rotate operation, as I have already shown you, if you are rotating something, you are pushing almost n items towards their right side, one after the other. So your rotate operation is not order 1, it is order n. So time complexity will go high for sure, right? So do you all realize that why this is going to be costly? Just type in yes or no. Right? Okay, great. You know, the only important thing that you have to keep in your head while implementing it is that you always keep on updating your index of first odd element in the right manner. Okay, that will help you to perform the correct rotation step. You can also do rotate with only order 1. What do you mean? Rotate with order 1? You mean order 1 space, or do you mean order 1 time? Can you rotate any part in order 1 time? You mean 1 times? You are saying just rotate 1 time. But even if you rotate it 1 time, it is going to take n amount of operations for that, right? So if you are rotating something like I showed it to you over here, right? Let's say you want to rotate it by 1 unit, you want this to come over here and you want everything else to go right by 1 unit. So rotate operation is going to be costly, right? If you mean time complexity, I want you to tell me that how do you want to perform rotation in order 1 time? I don't believe that will be possible. Yeah. Okay. So can everyone implement this idea? Yes or no? Okay. So let's say you had an array like this, 5, 7, 9, 2, 4, 11, 6. Yeah. So you somehow find the first index where odd element is present. Here that index is 0. And now you start iterating on the array. Whenever you see that you have found an even element, then what you will do is you will just rotate the part from idx to j. When you do that, we all know that 2 will come here and 5, 7, 9 will be pushed to right. So 2 comes here and 5, 7, 9 get pushed here. And the next step that you will do will be idx plus plus. So that now the first index of odd element gets updated, right? Now you will move on to the next element. Again, it is even. Again, it is even. So you will rotate the part from here to here. That way 4 will come here and your 5, 7, and 9 goes there, right? And then you will change your idx to idx plus plus again. So your idx again comes here. Then your j goes here. And then again, you will, this time it is odd, so you won't do anything, okay? Now, when you come here, you realize it is even. So again, you will swap it, rotate it from idx to j. That's why 6 will come over here and 5, 7, 9, 11 will be pushed towards the right side. So think why this approach works, or if at all it has some kind of edge cases, then what those edge cases will be, how to solve for them. Okay. However, there is one interesting thing in this, and we'll be talking about that. Reverse array, then reverse till k. No, that's how. No, that's not. Look, whenever you are reversing till k or reversing after k, reverse operation is never, order 1 operation. Reverse operation is going to be order n. I know you're talking about the optimal approach, but even in that, the time complexity is order n, if you take a look at that. Cool. There is one thing that you will have to be careful in this approach. When you're tracking this index, how will you initialize it to? So let's say you have an array. How will you initialize it to? You need to initialize it to an appropriate value, right? So that, okay, one of you is saying -1, others. Let's understand it. So consider this case only. First you had 2, 4, and then you had an even element, let's say 5 over here. Odd element 5 over here. So when you come at j and you realize you have an odd element, okay. So when you are seeing odd element, then you are doing nothing, right? But whenever you see an even element, you would want to do something. So if I change it to something like 6, then you would want to perform a rotation from idx to j. But think of it in this way. If the first odd element in your actual input comes later, if it comes at, let's say 7, if it comes at this index, which is j plus 1, in that case, would you want to do anything? Anything that you would want to do in this situation? You don't want to do anything, right? Because this 2, 4, 6 is already coming before the first odd element, which is 7, right? So you don't need to do anything with them. So you can, one way to take care of it is, you can just scan through your array and you can figure out the first index where odd element is present, and you can store that in this idx variable, correct? And now what you can do is, if you ever see that there is an even element which is coming before idx, then you don't need to do anything, okay? But on the other hand, let's say if you were here and you saw an 8, then it makes sense. Then it makes sense to perform a rotation from idx to j, and that rotation should be 1 unit rotation. That way 8 comes here and 7 goes there, and then you update your idx to idx plus plus. So this is one thing that you need to take care of. Okay, there are several other ways also to do it, but this is one way, that you first calculate the the appropriate value of idx. Just scan through the array and find the first odd element. Okay, does that make sense? Yes or no? Can somebody quickly talk about the time complexity? Okay, I'll talk about it once again. There's nothing special in it. Look, what do? Whenever you see an even element, then you rotate the part from idx to j. And what is this idx? This idx is the index of the first odd element, right? Now, if the first odd element in your array is coming later, if let's say you are here and the first odd element is coming later, then would you want to do anything? You would not want to do anything, right? Only if you are after this first odd element and then you realize you get an even element, then you would want to perform a rotation. Otherwise, you won't want to perform it. It's just a tiny thing. If you observe it carefully, you'll understand this needs a handling and how is it to be handled. Yeah, so time complexity will be order n square. Why? Because your rotation is going to cost you order n every time, and you are going to traverse the array for n times. So it is going to be around n square, right? Clear to all? Yes or no? Okay, great.